Hi class, for this sections we going back to finding limit. In chapter 2 we find a limit by the limit law, and I remember I showed you that sometimes we have to simplify first before we take the limit. Now this time we don't have the tool to simplify the limit. Sometimes we cannot simplify the function before we take the limit, so we have something called the L'Hopital rule. Okay, now in order for us to use the L'Hopital rule, you need to check the condition carefully. So make sure you take you read the L'Hopital rule carefully. So you see right here we have the limit go to 0. The limit is positive and negative infinity, and if we have the quotient, uh, all we have to do is keep taking the derivative of the function top and bottom. All right, so before we get into some example, I want to make sure you are aware of this. You need to verify the condition regarding the limits of f and g before you apply L'Hopital, before you take the derivative. So L'Hopital rule is also valid for one-sided limit and limit at infinity and negative infinity. Now, when you use L'Hopital rule, this is very important because I saw it so many times when we're dealing with quotient here. So when you use the L'Hopital rule, you differentiate the numerator and the denominator separately. So you do not use the quotient rule. Okay, so hopefully you are aware of that. Let's go into example 1. So first, I need to check the condition. Limit ln of x approaches to 1, which is limit of 1 equal to 0. I'm sorry, ln 1 equal to 0. The limit as x approaches to 1, 1 minus 1 is 0. So what we have is 0 over 0. Therefore, you can apply L'Hopital. So I apply L'Hopital. I take the derivative of ln x. I take the derivative of x minus 1. Limit over here is 1 over x. Limit on the bottom is just 1. So you simplify it, you get 1 over 1, which is 1. Okay. Example 2. You see right here, I have to check the condition. Limit of e of x as x approaches to infinity, it's gonna go to infinity. On the bottom, we got x squared. X approaches to infinity, we're gonna get infinity. So it's indeterminate infinity over infinity. Therefore, I'm allowed to take the limit. I'm sorry, I'm allowed to apply L'Hopital. So I take derivative. When I take the derivative, I still ended up with infinity over infinity. So I'm gonna take the limit one more time. I'm sorry, I'm gonna take the derivative one more time. So when I take the derivative, e to the x power is still e to the x power. But when I take the bottom is 2, right? So now we know that the limit is gonna be infinity because we have the infinity in the numerator here. Okay? All right, moving on to example 3. So what I have right here is we want to calculate the limit ln of x over square root of x. So once again, I checked the condition. So when I checked the condition, I ended up with infinity over infinity. So when I take the limit, you can see right here, we have 1 over x. On the bottom, we have 1 over 2 square root of x, which also indeterminate because we get 0 over 0. So what can we do? Let's just simplify it, right? So if I simplify, you see how I move it to the top. Now when I simplify it, I ended up with 2x square root of x, right? Now because it's negative, I put it on the bottom. Now, when you take the limit, you see the bottom goes very large, so it approaches to 0. So now we know that the limit is 0. Okay, so make sure you have to simplify first and then you take the limit. If we still have 0 over 0, it's gonna go nowhere and then we keep taking the derivative, right? So make sure you simplify. Okay, let's take a look at this example right here. So what I want is to take the limit x goes to pi from the left, sine of x over 1 minus cosine of x. I take the derivative, I get, the derivative of sine of x is cosine of x. The derivative of the bottom is going to be sine of x, right? Now, if you do it this way, you ended up with negative infinity. However, there's a big error in here. We did not check the condition. The condition from the beginning, you have to see, you have to take pi, you plug it in here. You take pi, plug it in here. See if you get 0 over 0. See if it's indeterminate, right? We didn't check the condition. So if I plug it in, I get 0 over 1 plus 1, which is just 0. So the limit in fact is 0. So make sure when you look at the problem, make sure you try to find the limit first before you jump right in and take the derivative and using l'Hopital. Okay, so make sure you check the condition. What we have right here is called indeterminate products. So you see right here we have the limit f of x equal to 0 and the limit g of x equals to infinity. So it's not clear if we multiply, if we find the limit of the product. So this is indeterminate. So we need to convert to quotient so we can get 0 over 0 or infinity over infinity. In that case, after we get that, we can apply l'Hopital. Okay, now notice that f times g, if I change it to quotient, I ended up with f over 1 over g, right? And then yeah, you can just do the opposite. Okay, so pretty much you can go from product to quotient easily. So what do we have here? We have the limit of x times ln x. X approaches to 0 from the right. If I check the condition, I get the limit of x equal to 0, the limit of ln x equals to negative infinity. Now I'm going to rewrite. You see how I rewrite? X equals 1 over 1 over x, right? If you do the division, you're going to end up with x. So what do we have? We have the limit of this. It's going to go to infinity, right? So now I'm going to rewrite. So instead of writing as a product like this, I'm going to put ln x over 1 over x. Now I take the derivative, top, I get 1 over x. I take the derivative of the bottom, I get negative 1 over x squared. Simplify it, I get negative x. So the limit is 0. Okay, so make sure you rewrite, you take the derivative, you rewrite, you simplify, and then you take the limit. All right, so what we have right here is the difference. So you have f minus g, which is infinity minus infinity. Once again, I'm going to convert to quotient so we can use l'Hopital. So compute, we have that minus 1 over x minus 1. So you see right here we have an infinity minus infinity, right? Which is indeterminate. Okay, so how do I combine it? LCD. So I'm gonna multiply and then change it to LCD and then I multiply right here. LCD, I simplify it. I ended up with 0 over 0 if I take the limit. You see, now I have the indeterminate. So what we have, we can apply l'Hopital. So we're going to take the derivative, applying l'Hopital meaning taking derivative, top, taking derivative on the bottom. Notice that this is product rule for x minus 1 times ln x. So when I take it, once again, I simplify it. You see, I simplify it. So I ended up with this part right here. Now, what do I have? I still have 0 over 0 if I take the limit. Therefore, I take the derivative one more time. So when I take the derivative one more time, I ended up with this one. Now, if you plug it in, you're going to get 1 over 2. Okay. So we have a couple of things. We have the powers, the indeterminate powers. So you have 0 to the 0 power, infinity to the 0 power, or 1 to the infinity. Okay, so make sure you rewrite. You see right here y, f of x, y equals to f of x to the g of x power. If I do ln, I apply ln on both sides, I can take the power to the front. And then I have ln f of x, right? Or I can always apply the e function. So I get e to the g of x times ln f of x. So let's try it. Now, you see right here, we have 0, 0, right? So we have the power, the indeterminate power here. So make sure that we know that 0 to the x power equal to 0 for all x. X to the 0 power equals to 1 for all x, except for x equal to 0. I want to rewrite my original function. So instead of x to the x power, I'm going to put e to the ln in. Notice that e to the ln cancel out here. Okay? But we're going to keep it that way. And then we rearrange it so we get e to the x power times ln x. Now we know from the previous problems that x, the limit as x approaches to 0 from the right, x times ln x is going to give you 0. So in fact, if you take the limit, this one's going to go to 0. So e to the 0 is just 1. Okay? And that's going to be our solution for this problem. So notice that we rewrite. Okay? You rewrite and you apply what we know.